So physics is about understanding the world around us. That's why I study physics. That's why anyone would want to know more about physics. Now, I'm going to talk to you today a little bit about what's called Brownian motion. And it was discovered by this guy named Brown in the early 20th century, I believe. And he was looking at pollen on water under a microscope. And he noticed that these pollen spores kept moving in a really weird and random way. He could never predict where they would be from one moment to the next. We've all sort of experienced the same sort of random motion when we look at dust particles in a ray of sunlight. We've all been sleepy, waking up late, and maybe it's been a few days before you've cleaned, and so you've got a little bit of dust in your room, and you see this dust dancing around in the sunlight. Now imagine you wanted to, say, quantify exactly how this dust was arranged. So you could take a picture of the dust and look at where each dust particle is at any given moment. But then if you waited and you wanted to take another picture in order to see how their positions have changed, it would be really hard to follow one dust particle from one moment to the next, because these dust particles are what are called indistinguishable. You cannot tell one from the other. Now, the way in which we are quantifying this order is what's called entropy. And so it's a measure of how random and how, or not random, these dust particles might be arranged. And the same with these, say, pollen spores. If you were to take a snapshot at one moment and wait a little bit longer, you might see a change in entropy. And we know from the laws of physics that entropy always increases with time. And so you would see actually more randomness given more time. So is there a way that we can take something random and make it more ordered with time? So imagine we start with a deck of cards. Been shuffled already, and so it is highly unordered. We can say that it has a high degree of entropy. There is no rhyme or reason to which card follows the next. They're not organized by suit, by number, by favorite card. There is no order to the deck whatsoever. But we do have all 52 cards. We know our system quite well. Now imagine we take just one suit out of this deck. We'll pick the spades to treat first. So we'll take all 13 spades out of the deck and make our system 1/4 smaller. This way, a little bit easier to see the order or disorder of our system. So now we just have our spades separated, and we have the other 3 suits still in a state of high entropy, separated. And you notice that the spades are also still have a high degree of entropy. Now, they would have less entropy than the rest of the deck because we have now organized them in some way, right? They are all spades, but there is no order to. And so, is there a way that we can take these spades and introduce a numerical order to them? Now let's scale our system back up. Let's look at the rest of the deck. So let's see. So again, this deck is highly unordered. It has high entropy. There's no rhyme or reason to what card goes in what place in the deck. Until